Hi everyone, welcome back to my YouTube channel. I am Preeti and I'm back with another lecture in the DBMS series. So in the last lecture we learned about basic differences between B and B plus trees. In this particular video we would be learning about scaling in databases. So without any further ado, let's get started. So the very first question which would be coming to your mind is, why do we even need to scale our databases? What is the use case behind it? So let's just understand a normal architecture or a process of users sending a request to access the data present on the internet. So right now we are having a device that could either be your PCs, mobile or any computers. Now from this particular device you go to the browser. You make a request, consider www.facebook.com, google.com or anything. So here we have taken www.example.com. Now whenever you provide this particular URL, just to get the data from the server, what we do is we need to provide the IP address. So we need to fetch the IP address of this particular URL. So how we can fetch the IP address? So if this particular URL has been hit by the browser like in the previous times, or if the data is saved in the cache, first we do a lookup on the cache, and if it is present we provide that particular IP address. If it's not present, then we do a DNS lookup. So it will check in the cache of the browser as well as operating system if the IP address corresponding to this URL is present or not. If it's present, it will return the IP address here, and then device will take the IP address and do a connection with the server and fetch all the details. But if the IP address is not present, it will do a DNS lookup, that is a domain name server lookup. So it will pick the domain name and then it will provide the particular IP address. So here we have got the IP address. Now using this IP address, we make a request to the server, because whenever we are accessing any website, all the details like databases, backend functionality, static content, dynamic content relies in the server itself. So we need to make a connection to the server and then send a request to the server. So first we will try to establish a connection with the server using the TCP and IP protocols. Once we have established a connection with the server, we will pick the IP address and we will send a request to the server. Now server is having databases, static content, dynamic content, which is basically the backend functionalities. So server will process the request and then gives away the response in the form of HTTP status code along with the content. Now that particular content would be rendered and then it will be shown in our device. Now this is how the normal architecture of a user sending a request and then fetching the details works. So as the data increases or the number of user increases, the server also needs to increase its storage space. So because of that reason, what we do is the database which was present earlier in the server is now decoupled and made as a all-alone entity. So now we have a database as a all-alone entity. So now if the storage increases, that could be accommodated in the databases. So the request which is made by the user from the device will go to the server. Server will make the same request to the database, as all the data which was present inside the server is now present in the database. So all the request has went to this particular database, and now this particular database will give me the result and server will give me the response. Again, if you see this particular architecture, consider if there is any crash which has happened at the server. We won't be able to get the results, right? Because there could be multiple users who are making the request and server can't handle that much load. So there could be a crash in the server. There could be also a crash in the database. Then again, we won't be able to fetch our details. So this particular system is not scalable, because if there are more number of users who are coming and making requests, we need to accommodate that request, right? We can't say that the server has crashed or the database has crashed. That is a bad user experience. So this system is not scalable. As the number of user grows, it will require the scalability in our systems. So that is why scalability is needed. So how we can scale our databases? So there are two types of scaling. First one is a vertical scaling and second one is a horizontal scaling. Now what happens in vertical scaling? So in vertical scaling, if there are one server, right now server S1 is present. So what it will do is it will increase the number of CPUs as well as RAM of this particular server so that it can accommodate more number of requests. So this is what happens in the vertical scaling. But there is an extent to which we can increase the number of CPUs or number of RAMs in our system. That is why vertical scaling is mostly used in small businesses or where the traffic is not very much. Coming to horizontal scaling, so if there was one server earlier, in horizontal scaling we make more number of servers. So there are more number of servers or instances which are made. So consider if one server fails, what will happen? The other server server will accommodate the request. So in horizontal scaling, we increase the number of servers or number of instances. In vertical scaling, we increase the CPUs, cores or RAMs so that it can accommodate more number of requests, but only to a certain extent. So now coming back to the last example which we discussed. So there was a device. Now in the device, we open the browser, we provide the URL which we want to fetch or the website which we want to fetch. Then for that particular URL, we need the IP address so that we can go ahead and ask the server for the details. For the IP address, first we need to check in the cache of our browser or operating system if the IP address is present. If it is present, we will return the IP address, and then that particular IP address will be used to establish a connection with the server and get the details. If the IP address is not present in the cache, we used to do a DNS lookup, that is domain name server lookup. From here we get the IP address. Now the device using the IP address first will try to establish a connection with the server using TCP and IP protocols, then we'll send away the request to the server. Now in the last example, what was happening was, if there is only one server which was present and if there are more number of requests which is coming to that particular server, there could be a possibility that server won't be able to accommodate that particular load or that particular users. So because of which there could be a server crash or failure. So just to accommodate that, we are doing a scaling of the server. So now scaling, we are doing the horizontal scaling. So here we have horizontally scaled the server. Now there are three servers, S1, S2 and S3, in which what we have done is we have increased the server using the horizontal scaling. So now the server have been increased. So we can say now the crashing is accommodated here, because even if one server crashes, we have multiple other servers to accommodate the request. But now user is sending the request, there could be multiple requests, R1, R2, R3 by different user. So how the server will know, or how the user will know that which particular server will be accommodating the request? So for this we have a load balancer coming into picture. Now what the load balancer does is, if there is any load which is coming to the server, it will go ahead and see in which particular server the load is the least, or which particular server has the less number of requests. It will just go ahead and accommodate that particular request to that particular server which is having the lesser load. So it just balances the load between the servers. Like if there are huge load which is coming to our website, it will just go ahead and balance that particular load in different server so that the server crashing doesn't happen. So we have used the load balancer here, which can balance the request which is sent to our server. So send request to the server having lesser load. So that is what load balancer does. Now we have sent the request to the server and load balancer is taking care of all the requests. But here earlier we had only one database. Now consider there could be a possibility that that particular database also crashes. So for that reason also we need to do a database scaling. So for that particular database scaling, again we'll be using a horizontal scaling. So we will be scaling our databases so that it can accommodate more number of requests, and even if one database crashes or fails, there would be more number of database to accommodate the request. Now the scaling in databases happen in a different way. What way it happens? So basically it happens in a data replication way, where in the database we have a master database and then a slave database. So this is a master database, or this you can call it as a slave, or you can say agent database. Now the master database handle all the write operation which is coming, like if someone is creating an account, signing in, signing up. So all the write requests are coming to this particular master database. And in the agent or the slave database, we accommodate all the read operations. So we have two databases mostly. One is master database, one is agent or the slave database. In agent database, we accommodate all the read requests. In master database, we accommodate all the write requests. Now there is only one master database which is present in the scalable system, but there could be multiple slave databases or the agent databases. So here we have one master database and then there are two slave database. Now what happens if this particular master database crashes? So there are certain algorithms which make one of the slave database as the master database whenever there is a crash in the master database. Now here we have a master database and slave databases. Master accommodates all the write request and slave accommodates all the read request. Now how we will know that which particular request which is coming to our system will be going to which particular slave database? Because there are two slave databases. So if there is any read request coming, how we will know that which particular request will be going to which particular database? So again here also we introduce the concept of load balancer, which tells that this particular request will be going to this particular slave database. Now this is how we are scaling our system. All the crashes or the server failures or the database failures which can happen is accommodated now. But you know that if we are just querying into our database, it takes a lot of time and it is very expensive. Like a request is coming, then it is going to the server is making a query to the database. So that takes a lot of response time and that is very expensive operation, because of which we introduce caching. So what caching does is caching reduces the response time time, because here we store the values in the format of key and value pair. What will happen that whenever a device is making a request to the server will first go ahead and search in the cache if the data is present, because for some of the frequently used queries we can just go ahead and cache that particular data, because every time that query is made, that particular data needs to be sent. So it will go ahead and search if in the cache the data is present or not. If it is present, it will here only return the response and that will be rendered and shown in the device. If it's not present, then only it will go to the database and make a query, and that particular data will be gone to the cache, and then we can see in the response. So in this way we scale our system so that there are no crash, no failures. It can accommodate more number of user requests and we can get our desired results in desired duration of time. So this is how we can scale our system from 0 to, you can say, lakh or million of users. Now in the user journey, what happened? First was user action sending a request. Second was the browser parses the URL. Third was a DNS lookup to get the IP address. Fourth was establishing a connection with the server. Fifth was sending the HTTP request to the server. Sixth was server is processing the request. Seventh was browser receives the response. Eighth was displaying the web page. And ninth was caching the data. So in this way the user journey happens. Now the user sends a request by entering the URL or clicking a link. The browser then translates the domain name into IP address through DNS lookup, establishes a connection with the server, sends an HTTP request and receives the response. So this is how the user journey was happening. Now the browser then processes this response, renders the web page and display it to the user. So we get the static and dynamic content from the server. Now it gets to be rendered and then it is displayed to the user. The process involves multiple layers of networking, data transfer and client and server interaction, all working together to deliver the desired content to the user screen. So everything works together and we get the desired result on our screen. Now scaling in database is a crucial topic in development, mostly when the application grows and the volume of data increases. So whenever the application grows, the volume of data increases or the number of user increases, it's best to scale our system. Now there are some scaling techniques which are present. First one is vertical scaling, that is scaling up. Second one is horizontal scaling, that is scaling out. Third is database partitioning. Fourth is replication. Fifth is sharding. Sixth is caching. And seventh is load balancing. So let's learn about each and every one of them in depth. So the first one is vertical scaling. As discussed in the last slides, that what we do in the vertical scaling is we increase the CPU as well as the RAM of our server so that it can accommodate more number of requests. But there is an extent to which only we can increase our CPUs as well as RAM. So if there is a server, we increase the capacity of instances of RAM and CPU so that it can accommodate more number of requests, but only till a certain extent. So vertical scaling involves increasing the capacity of single database server. Now in vertical scaling, how we can vertically scale our system? So first one is adding more resources. So upgrading the server by adding more RAM, faster processors or larger or quicker storage. So whenever we add more RAM, faster processor or larger or quicker storage, we can scale our system. This helps the server to handle more number of requests and store more data. Now coming to the next pointer, that is improving performance. So tweaking the database settings, optimizing queries and indexing the tables to make the better use of hardware. So we can tweak the database settings, optimize our queries and index our tables to make the better use of our hardware. Now coming to the third point, that is upgrading to a stronger machine. So moving the database to a more powerful server, like switching from a regular server to a high performance cloud instance. So whenever we switch to a high performance cloud instance, we can do the vertical scaling and we can get our data very fastly and very quickly. Now, why vertical scaling is also called as scaling up? Because here we increase the more number of CPUs as well as RAM. So we scale up our system or the same server only in which we are increasing the number of CPUs as well as RAM. Now, what are the advantages of vertical scaling? So it is easy to set up because it usually doesn't need changes to the app or the database structure. So we don't need to do any changes to the app or the database structure. We only need to increase the CPUs as well as RAM. So it is easy to set up. Now coming to the next point, it is simple to manage since everything is kept on one server. So since everything is present only on the one server, we can easily manage each and everything. We don't need to go to different servers to manage different things. Now coming to disadvantages, first one is limited by the hardware's maximum capacity. As I told that there is only one certain extent to which you can increase the CPUs as well as RAM. So there is a limitation. Now coming to the second point, so it is expensive as high-end hardware can be costly. So a high-end hardware can be very costly, because of which it is also very expensive. Now coming to the third point, that is single point of failure. So since there is only one server in which we are increasing the CPUs as well as RAM, what if the server fails? All the system will be go down, right? So if the server fails, the entire database goes offline. So if the server fails, the entire database goes offline, and we won't be able to process the request of different users, and it will be resulting into multiple 500s or server not found. Now coming to the next one, that is horizontal scaling, which is also called as scaling out, because here we are not scaling the resources of the server, rather we are scaling the server. So if there is one server earlier, we are adding more instances or more servers after scaling. So if this is server 1, server 2, server 3 and server 4. So horizontal scaling involves spreading the database workload across multiple servers. So whenever we spread the database load across multiple servers, we call this as horizontal scaling in terms of databases. Now this can be done in different ways. First one is database replication. Replication is the process of copying the data from one main server, master, to one or more backup servers, that is slave. So I told earlier that in the database replication, we deal with the master slave, or you can say master agent architecture, where mostly master handles all the write operations and the slaves or the agent handles all the read operations. So here master slave replication, the master server manages all the write operations, while the read operations are distributed among the slave servers, or you can say agent servers. So this setup improves the read performance and provides redundancy. So it helps us in improving the read performance of our system, because there are multiple slave databases which is present, or agent databases which is present, which can handle multiple requests which is coming to our server, that is read request. Now coming to the next one, that is multi-master replication, which is also a part of database replication. In this, multiple server handle both read as well as write operations, increasing availability and the write capacity. So here multiple server handles both read as well as write operation, so that it can increase the availability as well as the write capacity. So however, it also introduces challenges in managing conflicts. So since if the multiple server are handling read as well as write operation, there could be some conflicts such as dirty read, where read and write read, write conflicts are occurring. So because of this multi-master replication, there could be some conflicts which can arise. In master slave replication, basically there is a master which handles all the write operation, and there is a slave which handle all the read operations in our database. Now coming to database sharding. Now what we do in database sharding, so consider if there is one database which is present here, which is having a table T. Now this particular table T is divided into different shards. So it divides the data between multiple tables in different database instances. So now T is broken down into T1, T2 and T3, and all these table relies in different database shard, that is D1, D2 and D3. So it divides the data between multiple tables in different database instances. So sharding involves partitioning the database into smaller, more manageable pieces shard, with each shard stored on a separate server. So the database is divided into different shards D1, D2 and D3, which is having different tables T1, T2 and T3, which is having all the data which is present in the table T. So there are two ways in which we can do the sharding. First one is range-based sharding, in which the data is divided based on the range of a particular key, such as data or user ID. So if there is a key which is present, on that particular key we will decide the range on which the data should be divided into different table. Like 1 to 5 is going to this table, then 5 to 10 is going to T2, then 10 to 15 is going to T3. So on the basis of range, we divide the data among different tables. Now coming to the hash-based sharding. So hash function is applied to the key, example user ID, to determine which shard the data should go to. So we apply the hash function on the basis of user ID or user key, so that we can decide that in which particular shard which particular data should go into. Now coming to the next way, that is caching. Now what happens in caching is we store the data of the most frequently asked queries. So it implements the caching layer to store frequently accessed data in the memory, reducing the load on the database. So we reduce the load on the database, because consider if someone is accessing netflix.com and if someone is going to the movies tab. So this is something which is happening like each and every time when someone is logging in. So what we do is, for that particular operation, we store that particular data into our cache, so that there is no DB operation which is happening, because DB operation can take a lot of response time and is also very expensive. While if we use caching, we can get it in very lesser response time. Now coming to the next one, that is load balancing. So distribute the database queries across multiple servers using load balancer to prevent any single server from becoming a bottleneck. So what the load balancer does is, if there are multiple requests which are coming into our system, our R1, R2, R3. Load balancer decides that which particular request will go to which particular server, so that there is no one particular server which is being a bottleneck for anything. So it decides that which particular request will be going to which particular server. Now coming to the next way, that is partitioning. So it divides the large table into smaller partition that can be queried independently, improving the query performance. So what happens that if there is a database server, in that particular database server, if we have a table T, it will divide this particular table into different partition, that is T1, T2, T3 in the same database server, so that that particular smaller partition can be queried independently. So it divides the data which is present in this particular T table into multiple table in the same DB instance. So it divides the data which is present in this particular T table into multiple table into the same DB instance, so that we have smaller partitions of table and the queries can result in a faster duration of time. So this is how we can scale our databases. I hope you like this video. So if you like this video, please hit the like button. If you're someone who is new to my channel, can go ahead and watch out the tech content first. And if you find it useful, can go ahead and subscribe. Also, if you have not followed me on my social media handles, you can go ahead and follow. The links are in the description. Till then, take care, keep learning, keep growing, keep smiling. Bye all.